Hello everyone, welcome to this tutorial which introduces us to the basic of Arduino. Arduino is an open source electronic platform based on easy to use hardware and software. The Arduino board is able to read inputs, for example, inputs from light sensor, which we call the light dependent resistor or the photocell, and then being able to execute a command based on that. Also, the Arduino can also accept inputs from a motion sensor. Okay, when motion is detected, it sends in also an output. And we can also program the outputs to perform certain functions. For example, if the light dependent resistor detects that the place is getting, or that the environment is getting dark, now turn on the light. Also, the PIR motion sensor, which is the passive infrared motion sensor, when it detects that, okay, there is a motion in the environment, then send a message alert or ring a bell, or let there be an alarm via a particular speaker system. The same thing, it can also send messages based on particular inputs that is being received. So those are some of the features of this Arduino. Also, we used the Arduino programming language, which is based on wiring, and also the Arduino software, that's the IDE, which is based on what? On processing. At basics, the Arduino uses the C++ programming language. We have different types of Arduino boards which are used for different purposes or application areas. They consist of both microcontrollers and a part of the software or integrated development environment that runs on your PC, used to write and upload computer codes to physical board. Now, some of these boards include the Arduino Uno, the Arduino Mega, the Arduino Nano, the Arduino Micro, the Arduino Leonardo, the Arduino Duo, the Lillipad Arduino boards, Arduino Bluetooth, Arduino similar, and so many of them. All this enables us to perform specific functions or control different types of electronics components. Now the question is, why Arduino? Arduino simplifies the process of working with microcontrollers and offers some advantage for teachers, students, and interested amateurs over other systems. One, it is inexpensive. It is cross-platform. It has simple, clear programming environment. It is open source and extensible software. And then we also have, because it's open source and extensible hardware. For example, it is most Arduino boards are relatively inexpensive compared to other microcontroller boards. The least expensive version of Arduino module can be assembled by hand, and even the pre-assembled Arduino module costs less than $50. For example, I can get a complete Arduino kit in Nigeria at the cost of 17,000 kits. That's a microcontroller plus other sensors such as the light dependent resistor, the temperature resistor, the transistors, and other electronic components that comes with this for different Arduino projects or different robotics projects. Then we said is cross-platform. The Arduino software IDE runs on Windows, Macintosh operating system, and Linux operating system. Most microcontroller systems are limited to Windows. Now, we said it's also simple and it has clear programming environment. The Arduino software IDE is easy to use for beginners, yet flexible enough for advanced users to take advantage of, as well as for teachers. It is conveniently based on processing programming environment. So students learning to program in that environment will be familiar with how the Arduino IDE works. Now, it's open source and extensible software. The Arduino software is published as open source tool available for extension by experienced programmers. The language can be expanded through C++ library, and people wanting to understand the technical details can make the leap from Arduino to the AVRC programming language on which it's based. Similarly, you can add AVRC code directly into your Arduino programs if you want to. And then the last thing we discuss here is that it is open source and then extensible hardware, meaning the plans of Arduino boards are published under Creative Commons license. So experienced circuit designers can make their own version of the module, extending it and improving it. Even relatively inexperienced users can build the breadboard version of the module in order to understand how it works and save money. Now, the basic component of Arduino Uno kit. The Arduino Uno is a microcontroller board based on the Atmega 328. It has 14 digital input/output pins, of which 6 can be used as full width modulation outputs and 6 analog pins, a 16 MHz ceramic resonator, a USB connector, a power jack, an inter-circuit serial programmer header, and a reset pin. As you can see in the diagram, we have 7 to 12 volts DC input, and then the USB to computer where we upload the program, and then we have the reset button. We also have the ICSP, which is the inter-circuit serial programmer for USB interface, and then we have the I2C, which is the inter-integrated circuit serial clock, and then that of the serial data pin. You can see them there. We also have the pin 13, 12 down to pin 0, which are the digital pins, and then we also have the analog pins A0 to A1, and then we have the other power pins here, the ground, the 5 volts, the 3.5 volts, and the rest of them. Now, the Arduino Uno kit comes with different components. This involves both electronic components and then the sensors. At the basic level, in your Arduino kit, as a student, should come with the following. You should have a piezo, or what we call the buzzer. We should also have maybe the temperature and humidity sensor. You should have, that's for measuring temperature and humidity. We should also have what we call the relay module, which helps us in converting the AC, that's the alternating currents to the direct current. The voltage, the maximum voltage our Arduino Uno can tolerate is roughly let's say 5 volts. Yes, but our AC comes with, ranges from 220 and above, or let's say 240, as in the case might be in Nigeria. So you see, it cannot, so you connect that directly to your board, it will just destroy it. Then we also have the LEDs, we have the fire, or what we call the flame sensor. We also have the infrared sensor, and then the remote for the infrared. We also have several transistors. We can see we also have resistors, LEDs, the LCD, which is the liquid crystal display screen, which we can just implement some simple robotics project with it. We can see we have the servo motor and the rest of them. Then you can see the cable, the USB cable for connection, and then these other cables we call the jumpers, and one of the most important, the breadboard, which we use it for prototyping. So thank you for listening, and remain blessed. Thank you.